Alright folks, so in this video we're going to explore given a linked list, how I can print every single element in that linked list starting from the head element to the very last element of my linked list. So to solve the problem here, what I'm going to do is I'm going to first draw some kind of a linked list here. So let's draw my first node. Okay, that's my first node of my linked list. This is my second node of my linked list. And this over here is my third node. And let's just have one more node here. I've got 4 nodes in total of my linked list. And what we have learned in class is that a node is something, we had come up with this idea of a node class where every node instance had 2 entities, the element and a next pointer. So to draw them, I'm just going to use a slightly different color where in fact, let me use a little, let's not use green there, maybe let's use pink. All right, this is a little bit better. So this pink region over here is my element, is the element of my node, and this blue region is basically the next, is the reference next that happens to point to the next node of my linked list. So with that idea, what we're going to do now is we're just going to tie up our our nodes here to make it a linked list. So let's see, what color can I use here. Let's create a head pointer. That's our head pointer. Okay, in this case a head reference that is pointing at the first node of my linked list, and then I'm going to use my blue color here. That is my next reference, is the reference that happens to point at the next node of my linked list. Okay, so again, just to keep things a little bit clear here, everything in yellow, whatever you see in this yellow, this entire thing is a node. Okay, and this region in pink over here is called the element. Okay, and for our discussion here, we can think of element as just being an integer, just some primitive int type. Okay, and this color in blue over here is basically the next. It is the next reference that happens to point. It just happens to point at the next node of my linked list. Okay, just as head points at the first node of my linked list, next points at the next node of my linked list. Okay, so with that, let's just complete this. So let me again be a little bit consistent with my colors here. So that's that. Then I've got my pink, and likewise this is pointing to the last node of my linked list. Now the interesting discussion here, what we had in class, was how would I know that this node over here is the last node of my linked list. The way we do this is I'm going to have my next reference for this node pointing at none. Okay, so with this picture in place here, let's just give some values here. So let's say this element over here contains a value 1. Okay, so let's again 1, and again it's not a good color there. Let me use green. Okay, so that contains the element 1. This contains the element 2. That contains the element 3, and this contains the element 4. All right. So my first question here is to write a function. Write a function that prints out every single element of your linked list, starting from head, going all the way up to the last node. So what you expect to see when this function is implemented correctly is the order 1, 2, 3, and 4. Okay. So we're going to do this function in 2 ways. We're going to do this recursively, and we're going to do this non-recursively. So let's just draw a line here where everything on the left hand side, in fact this line isn't good, so I'm just going to draw using my ruler here. So let's just draw a line where everything on the left is going to be the recursive implementation of this linked list, and the right hand side would be the non-recursive implementation of my function. Alright, so let's come up with a name here. So I'm going to say def print forward linked list. Okay, and I'm just using F over here to kind of denote that everything will be printing starting from the head tail there. Okay, so that's the name of my function. Excuse me. So this function over here takes in a parameter. It takes in a single parameter, which is my head. Okay, it takes in my head over here, and the code over here is going to print out. It's going to print out every single element of my linked list in a recursive. So this is my recursive implementation, and this piece over here is my non-recursive implementation. Okay, so how do I print out the recursive implementation here? So to print out a recursive implementation here, I'm going to start off with the base case. And the base case over here is that if my head is none, okay, it just means, think about this, if my head is none, if my head over here is none, meaning I'm essentially having a empty linked list. Okay, if I'm going to start off this function at the very first time with head being none is my empty linked list. And if it's an empty linked list, I'm just going to return because it's nothing to print. I'm just going to return back. All right. Otherwise, if this isn't an empty linked list, otherwise, okay, if this isn't an empty linked list, what I'm going to do at this point is I'm going to say, instead of putting an else over there, let's just do it this way. I'm going to say print whatever is head dot. How do I get the element? Out of this node here? In order to get the element out of this node here, I'm going to say head dot element. Okay, and again I'm using a pink color there just to signify that head is this reference pointing at the entire node, and from that entire node I'm interested in just getting the element out. So just print out that element. Once that element has been printed out, meaning you're essentially done with this entire node. This piece of the problem is done. And because that piece of the problem is done, what is remaining now is the remainder of the linked list. The remainder of the linked list must be printed out, which is this entire thing. Which is the function that is going to print out every single element of this smaller linked list? And you get the idea with recursion. With recursion, the first thing that you do is that your problem size must reduce. It must reduce so that it converges to this base case. Okay, so this is a smaller problem size, and you're going to print out every single element in the smaller problem size. And the way to do that is I'm going to call my recursive function again. So that color was the pink or the green here. So I'm going to say print f L and just pass in the remainder of my linked list. What is that pointer? What is that reference that points to the remainder of my linked list? That reference that points to the remainder of my linked list is this reference right there, next. How do I get hold of next? In order to get hold of next, I must get hold of this node there. What is that reference that points at this entire node? The reference that points at the entire node is head. How do I get next out of that head there? The way to get that next is head dot next. Okay, and this is the recursive implementation to print out every single element of my linked list.